In this video, I'm going to show you how to graph quadratic equations in standard form, vertex form, and intercept form. First form we're going to talk about is standard form. Standard form for a quadratic is y equals ax squared plus bx plus c. And some key formulas that you can use. For the axis of symmetry, AOS, x is equal to negative b over 2a. Okay, so let's do an example. Here's an example. Let's graph y equals 3x squared minus 6x plus 4. First thing you need to do is recognize that this is in standard form. This equation is in standard form. 3x squared minus 6x plus 4 follows the form ax squared plus bx plus c. So we can identify a, b, and c. A is 3, b is negative 6, c is 4. We can apply the formula for the axis of symmetry of x equals negative b over 2a to find the equation for the axis of symmetry. X equals negative 6 divided by 2 times 3. Two negatives make a positive. 2 times 3 is 6. Positive 6 divided by 6 is 1. Okay, so the axis of symmetry is that x is equal to 1. So at this point, what I like to do is draw the axis of symmetry. I do this by a vertical dashed line, like so. And another point you need to find is the vertex. Now, with parabolas, the vertex lies directly on the axis of symmetry. That's not a very good one. But here's a parabola. There's the axis of symmetry. The vertex lies right on the axis of symmetry. So what you could do is take x is equal to 1, substitute it back into your original quadratic equation to find the y value. So let's go ahead and do that. We got y equals 3 times 1 squared minus 6 times 1 plus 4. 1 squared is 1. 1 times 3 is 3. Negative 6 times 1 is negative 6. 3 minus 6, negative 3 plus 4 equals 1. Okay, so the vertex is at 1, 1. Let's plot the vertex, 1, 1. Now looking at the equation, a is positive, so this is an opening up parabola, and if it was negative, it would be opening down. We could take the c value, 4, as the y-intercept, 1, 2, 3, 4, and plot that point. But let's, for example, say that you don't necessarily want to just plot the y-intercept and reflect across. A process you could do is the axis of symmetry crosses x equals 1. Go 1 unit forward or 1 unit backward from 1. So 1 plus 1, that's 2. If we substitute 2 into our quadratic, I'll do that work up here, we get y equals 3 times 2 squared minus 6 times 2 plus 4. 2 squared is 4. 3 times 4 is 12. Negative 6 times 2 is negative 12. Those go to 0 plus 4. This is evaluated at 4. So the point I put in 2 into my function, out came a 4. The point 2, 4 lies on the graph. So we go over 2, 1, 2, up 4, 1, 2, 3, 4. Here is the other point. Parabolas are symmetrical. The dashed line is the axis of symmetry. This point is 1 unit away from the axis of symmetry. Reflect across, and we have the other point right there. And you can see that that's the y-intercept, and we just went about it a longer way, but that process will work for any parabola in standard form. So here we go. Let's go ahead and graph our parabola. Remember, these things are rounded, not V-shaped, and I know my graph sort of looks a little sloppy, but bear with me. Like so. Okay, there's graphing a parabola in standard form. Okay, next form we're going to talk about is vertex form. Vertex form for quadratic equations is y equals a times x minus h squared plus k. Key formulas: the vertex is at hk, and the axis of symmetry x equals h. So here's an example. Let's do f of x is equal to negative x plus 3 squared plus 5. Okay? This example is in function notation and it follows the form, vertex form. I'll write vertex form right here, of quadratic equations. What you can do now is identify all the variables except x and y. So we have a, h, and k. We can identify those. A is negative 1. H is negative 3. The reason it's the negative 3 and not positive 3 is because this form has this negative sign. Two negatives will make a positive. That's why in order to get this positive 3 you have to substitute h with negative 3. K is 5. The vertex is at hk, therefore the vertex is at negative 3, 5. And the axis of symmetry is at x is equal to h, which is x is equal to negative 3. Okay, we have a lot of information. Let's start plotting some of our points. Negative 3, dash line, vertical dash line, going through the parabola. Negative 3, positive 5. 1, 2, 3, 4, 5. Okay? And, here's our vertex. Next process we need to do is find another point on our parabola and reflect across. The axis of symmetry goes through x is equal to negative 3. The next input you want to put into your function to find another point, choose one or two back or forwards from the axis of symmetry. You don't want to pick one that's like 5 or 10 units away from the axis of symmetry because these shapes, these parabolas, get really, really big very fast or really, really small very quickly. So I'm going to choose, this is negative 3, the axis of symmetry is negative 3, I'm going to choose, let's say, negative 2. Let's substitute negative 2 into our function f of x. F of negative 2 is equal to negative 2 plus 3 squared plus 5. Negative 2 plus 3 is 1. 1 squared is also 1. Negative 1 plus 5, and I'm off the chart. Negative 1 plus 5 is 4. That means the point negative 2, 4 lies on our graph. Negative 2, 4. So let's go to negative 2, to left 2, up 4. Here's the other point. This point is 1 unit away from the axis of symmetry. Reflect across, go 1 unit the other way from the axis of symmetry, and there's our other point. Let's make our graph nice and rounded. And I always like to kind of double check just to make sure I did everything okay. Looking at A is negative 1. This parabola should open down. Looking at this parabola, it does open down. It has a maximum. The maximum is at 4. Okay, or the vertex is the y coordinate. Okay, let's go on to the next form. The next form is intercept form. So I'm going to write the general form for intercept form. Y equals a times the quantity x minus p times the quantity x minus q. Key formulas for this: intercepts are at p0, and q0, and these are the x intercepts. Axis of symmetry, AOS, x is equal to p plus q divided by 2. Here's an example of a function in intercept form. Let's use h of x is equal to x plus 1, x minus 3. you can see that this function is in intercept form, so we can identify A, P, and Q. And be really careful with the form, the negative signs. A is equal to 1. It's not written there, but it's implied that there's a 1 there. P is equal to negative 1. That's how you get the positive 1 in the example. And Q is equal to positive 3. That means intercepts are at negative 1, 0 and 3, 0. And the axis of symmetry, x is equal to negative 1 plus 3 over 2. Negative 1 plus 3 is 2. 2 divided by 2 is 1. So the axis of symmetry is at x is equal to 1. Dash line going through the x-axis at 1. Let's plot the intercepts. The intercepts are at negative 1, 0 and 3, 0. The axis of symmetry always goes through the vertex, so to find a vertex, what you need to do is use 1 as your input to the function. Let's apply 1, or let's go ahead and evaluate the function with the input of 1. H of 1 is equal to 1 plus 1, 1 minus 3. Substituting 1 into the function. 1 plus 1 is 2. 1 minus 3 is negative 2. 1 times negative 2, negative 4. So the vertex is at 1, negative 4. So let's go over 1, down 4. Here is the other point, and that's the vertex. And we can go ahead and draw a parabola. It's probably the best parabola I've ever drawn, to be honest. No, this can be better. Anyways, what I'm going to be doing next for the next video is showing you, these are all quadratic equations that I've shown you how to graph. What I'm going to show you now is, on the next video, is quadratic inequalities, how to graph those. And then just have to involve some shading and what